Good evening, ma'am.
Good evening, Shweta. We'll just wait for other students for 2-3 minutes.
Yes, ma'am.
So let's begin the class. First of all, we will just solve a question. Even if you have seen the answer, the task is to solve the question. There is a concept in this question, and so we need to solve it. So, Shweta and Ritika, let's try to solve this question. Ritika, are you solving the question? Shweta, any progress in the question?
Solving it, ma'am, one sec.
Okay, good. And Ritika, what about you? Good evening, Anya. Just try to solve this question first.
Okay.
Okay. See, the trick is that look at the values of ionization potentials very carefully and just mark the point where you see a sudden increase in it. As you can see, the ionization potential is increasing, right? That is IE1, IE2, I3, 4, and 5. They are successively increasing. Where you find the maximum gap? See, if you notice carefully, you will see a gap between the third and the fourth. That is 37.9 and 259.3 electron volts, right? So that means after giving out 3 electrons, the element has become stable. Therefore, it is requiring very high amount of energy. That is from 37.9, it has moved to 259.3. Therefore, it can lose 2 electrons or give out 3 electrons to form MBR3. Right? Is it clear to all of you?
Yes, ma'am.
Okay, so can somebody share, say, Shweta, can you share what was your thinking process going on when you saw this question? I could not hear from you, Shweta.
No, I was a bit confused on like how to solve it, so I don't know.
Okay. In such a situation, I advise all of you to just put on your speaker and talk to me. I may be able to give you a hint. Right?
Yes, ma'am.
Okay, there seems to be some problem with my pen time, but I'll manage it. So next property which we will understand is electron affinity. Now, electron affinity or electron gain enthalpy, these are the two different names of the same property. By and large, we can say that it refers to the amount of energy exchange. Look at the word carefully, the amount of energy exchanged. That is, it can either be released or it can be absorbed. We'll just explain how and why we are saying so, that it is the amount of energy exchanged when one electron is added. Remember, in ionization enthalpy, we were taking out electron. In this case, what we are doing, we are adding an electron. And that is done only in the valence shell. Please remember, whenever you are adding electron, it is done only in the valence shell. The rest of the definition is same as what we learned in ionization potential, that it is added to an isolated gaseous atom. As a result, it converts into electron volt. So basically, you can note down its unit or how this energy is measured. It's measured in terms of electron volts per atom. Now, the last line or the last point is very interesting and important. If you recall, in ionization enthalpy, I said it is always positive because you have to supply energy to take out the electron. But in case of electron affinity or precisely electron gain enthalpy, it can be negative or it can be positive. That is, energy can either be supplied or maybe given out. So what we say, that out of successive ionization enthalpy or electron affinities, the value becomes positive, right? That means that When you take out one electron, it becomes uninegative. Now, what are you doing? You are adding an electron to it. So what will happen? You will have to supply energy, because since it is negatively charged, it will have a tendency to shed off that electron, isn't it? Are you getting it, my point? That second electron affinity value is going to be positive. First can be negative or positive, but the second will always be positive. Reason being, here you are doing something against its wish. That is, you are adding an electron to already positively charged ion, right? Now, how does it vary in a group, or what are the factors affecting it? Talking about the factors affecting it, I'm just trying to figure out what has happened to my pen. Okay. So, first of all, we will understand what are the factors which affect electron gain enthalpy. So what do we say in this case? That the nuclear charge, that is the electron at the center, which we have already understood in the previous session also. That affects the electron gain enthalpy, and more importantly, atomic size, right? These are the two factors which affect the electron gain enthalpy of the system, that can be an atom or that can be an ion. Now, talking about what happens to it in a group. In a group, as you can see that it is decreasing, right? That means that as you are, the size of the atom is increasing. If this is the size of atom here, if this is the size of atom here, right? If you are adding an electron here, it becomes easier because its distance from nucleus is more, attraction is less. So you can easily add an electron into it. But there is an exception to this rule, or this trend rather. When we move from fluorine to chlorine, what would you expect? Ritika, what would you expect?
Ma'am, I'm not sure, ma'am.
Okay. So have you understood this term, this particular thing? Ritika, Ananya, and Shweta. Ritika, please reply.
Yes, ma'am.
The trend is clear to all of you, I believe, that as you can see, that as we are moving down the group, electron gain enthalpy is decreasing, right? So that means if I apply the same concept to group 17, that is halogen family, what should happen? What should be the trend? The electron affinity of fluorine should have been more, because we say it is decreasing. But as you can see, this one is higher, right? If you look at the numerical
Yes, ma'am.
now I think it is clear to all of you. Then we try to understand why it is happening. Why does it happen, right? So to understand that, we have to draw the shape of the, or the size of the two orbits, and the respective orbitals will be a bit difficult. So we'll manage it, or we will try to understand it with the help of orbits. So as you can see that in case of fluorine, the last electron is added to 2p5, whereas in case of chlorine, it is added to 3p5. If you have understood your chapter of structure of atom, the size of 2p5 will be smaller as compared to that of 3p5, or rather 3p orbit. So as pictorially, it may not be correct or it is definitely not correct, but we can have a pictorial image where you can see this is fluorine atom, which does not have a space to accommodate the 6th electron. Whereas this one is atom of chlorine, which apparently seem to have a comparatively larger space. The surface area of 3p orbital will be larger as compared to 2p. Hence, it can accommodate the incoming electron easily. That means the incoming electron will not feel much of the crowd over there, right? Or it can be easily accommodated. Therefore, you will have to spend certain lesser amount of energy. Technically, if you read what I have written on the slide, that is the precise answer to the question kept here, that why the electron affinity of chlorine is more than that of fluorine, right? So we say that the size of fluorine is smaller as compared to size of fluorine. And if you want to be more precise, you will say the size of 2p orbital is smaller than that of the 3p orbital, right? So the smaller the size, lesser will be the space, more will be the inter-electronic repulsion. Inter-electronic repulsion means the repulsion taking place between electrons, right? And so it will have a lesser electron affinity. Is it clear to you, Ananya?
Yes, ma'am.
Okay, I hope it is clear to all of you now. Moving
Yes,
to the
ma'am.
next. Okay, thank you. Now, as I have told you earlier also, that if a value of a certain property is decreasing in the period, then the vice versa is expected in a group. And if it is decreasing or whatever it is happening to it in a group, it will be doing the opposite in the period. So similarly, we can say that as we move from left to right in a period, the electron gain enthalpy increases, right? And that of neon, as you can see, which is a noble gas, its value is 0 because its valence shell is completely filled. Here, in case of beryllium and nitrogen, you can see the positive values. Why? The reason is simple. You have to look back there at their configuration. Beryllium was having 2s2. Now, can somebody tell me what was nitrogen? Nitrogen was? What was the configuration of nitrogen? Ananya? Shweta, can you tell me the valence shell configuration of nitrogen?
Yes, ma'am.
Yeah, what is that?
1s2, 2s2.
2p.
1 second.
2p3.
2p3.
2p3, correct.
3.
So 2p3, we have discussed in terms of financial enthalpy also. They are stable. Now, because they are stable, it will be difficult to take out or add the electron to them, because by doing so, they will become unstable. So therefore, the energy is not released, but you have to supply energy. Again, an interesting reasoning question can be asked from this section also. Moving to the next property, that is of electronegativity. Since all of you have done this chapter in your school, can somebody tell me some unique thing about electronegativity? Shweta, I'll begin with you.
I'm asking what do you mean by electronegativity?
Yeah. What is electronegativity? Can anybody define
It's
for me?
like gaining an electron to make the atom stable.
You're saying gaining electron, right?
Mhm.
So then what is electron gain enthalpy?
Mom, can I say?
Yeah, Ananya, please say.
It is the tendency of the bonded atoms to attract shared pair of electrons.
Can you be a bit slower and a bit louder? It is a tendency of,
Mom, it is the tendency of bonded atoms to attract shared pair of electrons.
that's correct. So electronegativity is the tendency to attract the shared pair of electrons towards itself. Ideally, the bond pair of electrons should be lying exactly in between the two, because the bond is formed between the two atoms by sharing an electron. Each one of them has contributed one electron each to this. So that means the electron pair should be lying exactly between them, right? But in case of elements like halogens and oxygen, they tend to attract the electron. As a result, the shared pair of electron goes closer to them. If I draw HCl, then the electron pair will be lying closer to chlorine, right? So therefore, we say they have a tendency to attract the shared pair of electrons towards themselves more as compared to the other elements, right? So this cannot be measured. Can anybody tell me that why it cannot be measured?
Ma'am, because it is only a relative number.
Very correct, Ritika. Relative means, see, if you have to measure something, the other things much, what Ritika said in the heading was correct, but we need to elaborate on it, that why can't we measure this? The reason being that proton and electron are oppositely charged and they have their certain properties. When you are trying to measure the attractive power of halogen or hydrogen or any other atom, then, and with that, of course, which is bonded to other atom, what it has to do, it must not do any other activity. That is, it must not repel the other electrons and it must not attract the other protons, which is impossible, right? Like, it's like a role play. If I'm going to play a role of a queen in a certain drama, you cannot stop me from being a human, but I can control my emotions for time being. But electrons and protons cannot do so, right? They if you have to measure that, if you want to measure their tendency, then they must stop doing any other activity, which is not possible. Therefore, we say electronegativity cannot be measured. There can be theoretical scales which are based on other properties of the atoms. The three scales which I have put up here are Pauling scale, Mulliken's scale, and Alfred-Roschow scale. Out of these three scales, Pauling scale is most important one. In fact, whatever data which we use to compare the electronegativities of the various elements is collected or sourced by the Pauling's scale. The second one is the Mulliken's scale. Alfred scale we hardly use. So what is a Pauling's scale? Let's find out. So Pauling's scale was given by Linus Pauling, and it is a comparative scale on which the electronegativity of fluorine is given as 4. Again, I'll tell you, like for quantum numbers, we say they are arbitrary numbers. Therefore, does not mean 4, 0 does not mean 0. In this case also, these are arbitrary numbers. The numerical values do not signify that quantity. On the comparative scale, the most electronegative element is fluorine, right? Having electronegativity assigned as 4, and cesium has lowest, that is 0.7. Similarly, the other important element is hydrogen. Hydrogen has electronegativity value assigned as 2.1, right? Now, this is an image. If you want, whenever you have to refer to electronegativity, I have found and corrected many values. So you can use it if you require to solve a very, very difficult level of a question based on electronegativity values. The basic questions which relate to electronegativity will be required, we will be required to do it in chemical bonding, where we talk about Fazan's rule and we talk about the ionic character in covalent bonds. So I'll appreciate if you people can note down the electronegativities of halogens, that is fluorine, chlorine, bromine, and iodine, then oxygen, sulfur, nitrogen, carbon, and hydrogen, and all the group 1 elements. Is it clear? Please note down these electronegativity values. They will help us in the next chapter. Are you noting down, Shweta?
Yes, ma'am.
Okay, once all of you are done, please let me know. Note it down, Ritika.
Yes, ma'am.
Okay. Now, any one of you have noticed that the electronegativity of nitrogen as well as of chlorine, both are assigned the value of 3. Why? And if I have to choose which is more electronegative, then which one I will choose? Please note down the question. Which is more electronegative, nitrogen and chlorine?
Ma'am, can you repeat your question?
I'm just writing, I think it was Ritika.
Yes, ma'am. Yes, ma'am.
I have written it on the board. Which is more electronegative, nitrogen or chlorine? Both have electronegativity as 3. I'll just put it as En value 3. This is again an important question. Students, please note down the answer. Should I tell you?
Yes, ma'am.
Okay, write it down. In case of similar values of electronegativity, element with smaller size has higher electronegativity. I think answer is clear. I'll explain it to you once you have written it. That if the electronegativity, write the complete sentence, that if En values are same, then element with a smaller size has higher electronegativity. I'm moving back to the previous slide where we said the electronegativity of nitrogen and chlorine is same. Now, between nitrogen and chlorine, which is having a smaller size, is it nitrogen or chlorine? Shweta, please tell me.
Can you repeat, please?
Which is smaller in size, nitrogen or chlorine?
Nitrogen?
I didn't hear whosoever said whatever.
She said nitrogen.
Correct. So what is the answer to the question? That although the numerical values of electronegativity are same for nitrogen and chlorine, still it will be nitrogen which will be more electronegative. If you have completed your chemical bonding chapter in your school or at your own, then you can understand the hydrogen bond between nitrogen and hydrogen will be stronger bond. Chlorine never forms hydrogen bond. We'll do it in detail when we talk about chemical bonding. So we did one scale, that was Pauling's scale. No details are to be done. Sometimes this question is asked in exams, that what is Mulliken's scale and how the electron affinity is measured using this scale. So here is the answer. You just have to, there are no details available for it, or not required, I'll put it that way. That it is used only to find the electronegativity of monovalent element. Monovalent means using this, you cannot find the electronegativity of oxygen. Oxygen is a divalent element, right? Monovalent element is sodium. We can have sodium, we can have chlorine, bromine, potassium. Divalent, we will have oxygen, magnesium. We are not talking about the charges. We are talking about the number of electrons lost or gained, right? And the formula which can be used to find out the electronegativity using Mulliken's scale is ionization potential. Here, IP stands for ionization potential and EA, that is electron affinity. It is the, I can say it is the average of IE and EA, right? Is it clear to you, Ritika?
Yes, ma'am.
Okay. So moving on to what is their trend? How does it change? As you know, we are almost at the end of the periodic table chapter. So I will say, just remember, I might have said it to you repeatedly. Just think about the position of sodium and chlorine whenever you are in doubt. Sodium is S block, this is P block, and they are two extremes of us. You understand that chlorine is most electronegative. So group 1, lithium sodium has to be having lowest electronegativities. So what happens? In a period, the electronegativity increases. As you can see, from the values for the elements of second period as well as for the third period, right? The electronegativity we say in a period will decrease from left to right, and in any period, let that be the second period or the third period. Now talking about the trend in a group. So as you have seen in the period it is increasing. So in a group it has to decrease, right? That tendency to attract the shared pair of electron decreases, right? Here is a comparison for group 1 as well as group 17. Now, the next we will solve a numerical. What is the correct answer to this question?
There is no unit.
That's correct. Because what I have said, when we were discussing the same concept, we said it cannot be measured. If it cannot be measured, then it cannot be having any units. So is it clear to all of you?
Yes, no.
Okay. Now talking about the metallic character. In general, even if I don't teach you metallic or I have taught you metallic character, can you predict what is a metallic character? One definition is here. The example is also here, right? I probably do not need to teach or preach you about it, but do tell me one thing. Between sodium, magnesium, and aluminum, which will be more metallic? I'm putting my question in a different way. Sodium gives out 1 electron. It gives out 2 electrons. And it gives out 3 electrons. So which should be more metallic, sodium or aluminum? I believe the question is clear to the class.
Is it aluminum?
Okay, who's that?
Aluminum.
Aranya, okay. What is the basis of your answer?
Metals lose electrons to gain stability.
Agreed.
So if a metal loses more electrons, I thought like it will be more metallic in nature.
Okay. What is your answer, Shweta?
No, I guess it's sodium because like it's in the first group. And it's an alkyl metal, so it has to just lose like 1 electron and its atomic radii would be like small.
Okay. Ritika, your answer?
Ma'am, it's atomic radii.
No, I'm not talking about Ritika atomic radii. I'm asking between sodium and aluminum. Which will be more metallic?
Sodium.
Okay. See, Shweta, Ritika, and Ananya. I'll address it to Ananya first because you said it will be aluminum. Please remember, whenever I said I will purposely putting a question in a different format. Before even answering this question, if I say that aluminum, then let's say put it as silicon, which has got 4 electrons. If somehow I manage to take out 4 electrons from it, does it mean silicon will be a metal? Probably no. Probably means certainly no, right? Because whenever we are comparing quantities, we give them the equal circumstances. Like this Monday, you are having a certain subject test. You are assigned a certain number of hours and certain question. All of you, the entire batch, will be given the same set of a question. We can compare only them. When I'm comparing the metallic character, I must be thinking only of taking out the first electron, right? So between sodium, magnesium, aluminum, and silicon, or even if you restrict it to aluminum, we have done it, or we have understood it, that sodium will be easiest one to give out the electron, because when you move from left to right in a period, ionization potential increases, right? So it will be most easy to take out 1 electron from sodium. 2 electron from magnesium will be most difficult because energy considerations. It has got a stable configuration, right? So the correct answer will be sodium, not aluminum. Shweta, I believe, Shweta and Ritika, your answer was correct, and maybe the reasoning was here and there. I'm trying to tell you or explain you the reason just because of the fact that in a descriptive question, you have to write a reason, and writing a reason must not take more than 2 minutes from you. Otherwise, you will not be able to solve the difficult question of, let's say, thermodynamics or equilibrium, the chapters like that. I believe it is clear to you that why sodium will be most metallic, because it can give out the electron most easily, and we have to compare only 1 electron. It has nothing to do with the quantities, right? Is it clear, Ananya?
Yes. ma'am.
Okay. Again, the same factor. As I told you, the metallic character will be dependent upon atomic size. I think Ritika said something about it. She's correct in that. The nuclear charge, that how closely it is associated with the nucleus, and ionization enthalpy, right? The lesser the value of ionization enthalpy, more will be the metallic character. So this is a pictorial representation. Please remember, I always say it's a pictorial representation. Atom is not like that. In case of, as you can see, in case of francium, you will have to take out the electron from here, this place, and in sodium, this place. That 1 electron will be least attracted towards the nucleus, because the distance between nucleus and the valence shell is highest. So it will be most easy to take out the electron from the valence shell of cesium. Hence, it will be rather francium. Therefore, it will be most metallic. I was saying cesium because francium is radioactive. It won't be available that easily, right? Now we know in a period, as the size is decreasing, ionization enthalpy is increasing, attraction is increasing, metallic character is decreasing. Or otherwise, it's obvious. I say that always remember sodium and chlorine. It's clear. Sodium will give out electron easily. Chlorine, on the other hand, will be wanting that electron back to it. So this will be least metallic. See, you may be very clear about these fundas, but some interesting questions are there which can be asked. That is one thing. And more importantly, I don't want you to have any pitfall in any one of them, right? And this class is about how to write an answer. Now, metallic, if we are clear, non-metallic is completely opposite of it. Non-metals will accept the electron. Again, we will not make the previous section's mistake, that we'll be always thinking in terms of taking out only 1 electron. If I have to compare it between, say, chlorine and oxygen, chlorine has 287, or I will take it fluorine then to make the comparison fair. Fluorine and oxygen. It has 6 electrons. It will have 7 electrons. You have to add 1 electron here and you have to add 2 electrons here. If you have to compare which one is more non-metallic, you have to compare only the first electron energy which is required to add the first electron to oxygen, right? So rest, we know it very well. When we move from left to right, the non-metallic character will increase. And non-metallic character, if it is increasing from left to right, then top to bottom, it should decrease, which is opposite of the metallic character, right? Again, same depend on the same thing. Then we know, have we discussed what are metalloids? Anybody can anybody define metalloids for me?
Ma'am, which has both properties of metals and non-metals.
Okay, I'll say make one correction into it, which have both properties, not replace the word by both by some, sorry. Which shows some properties of metals and some properties of non-metals, right? Not
Yes, ma'am.
exact, right? So that is for all of you, not only for Ritika. It's for everyone that the elements which show some properties of metals and some properties of non-metals are referred as metalloids. And they are very important for us because they are used in making mainly semiconductors. Without semiconductors, probably we should not have been connected. Semiconductors are integral part of the computers, mobiles, and almost all electronic gadgets. So this trend is clear to all of you. We will be moving to the next one. That non-metallic character is increasing from left to right, right? Then nature of oxides. Can somebody tell me the formula of oxide ion? What is the formula of oxide ion? We often talk about oxide ion, hydroxide ion.
O2.
O2, should I put it here or where?
Ma'am, the 2 comes in as a superscript.
Okay. Correct. It is O2 minus, right? Okay. But the group 1 and group 2 are deleted. Otherwise, we would have talked about the superoxides and peroxides also. Hydrogen peroxide, you will come to encounter someday. What is the formula of nitrite? Nitrate, you may be knowing. What is sulfite? What is sulfide? Any idea? Quickly, it just stuck to me. You must, to ensure that you remember the formula of ions, if I ask you to write the formula.
Ma'am, NO2 for nitrite ion.
Okay. Nitrite is NO2 minus, sulfite is SO3 2 minus, sulfide is S2 minus, sulfate is SO4 2 minus. If you don't remember them, please note them out because they may see. Now I'm talking about a question which has many chapters integrated. They may tell you that an element was discovered on, let's say, moon or sun, moon. Let's say Chandrayaan has recently gone to moon. The sample of the surface has a element, right? which resembles, let's say, group 2. Write the formula of its sulfide. Do you get my question?
Yes, ma'am.
Okay. That can be element belongs to, say, group 4 or 2 or 3, whatever you feel like. Write the formula of its sulfide. So the student has to know what is the formula, what is sulfide itself. I think my writing is legible and you are able to write down whatever you have to. Then we have, I forgot to mention, carbonate. Carbonate is CO through 3 2 minus. Then we have bicarbonate. Let's do till carbonate only, bicarbonate, and else we will do it some later day. It's enough for you to remember, right? So they talk about the basic nature of oxides and acidic nature of oxide. So first of all, let us understand what is the basic and what is the acidic nature of oxides. See, these oxides, what do they produce when they are dissolved in water? Here you can see the oxides of different elements of a period. Since they were of group, they were almost similar. So we will take the oxides of a period first. As you can see, or we have already understood, if we are not very familiar with sodium oxide, we are very familiar with the hydroxide of it, sodium hydroxide. We know it is basic because it is producing OH minus ions. Now what we are doing, we are trying to develop a correlation. Sodium oxide, when dissolved in water, it will produce, I'll write it here. It will produce NaOH. Whereas if when I have SO2, sulfur dioxide, it will react with water to give us H2SO3. This is sulfurous acid. Quickly, can somebody tell me the formula of sulfuric acid?
H2SO4.
Correct. So now you can understand the metal forms oxide, which are sodium hydroxide is basic. Metallic oxide will be basic, whereas the non-metal oxides will be acidic in nature. So what we can say, that when we move from left to right in a period, the basic character decreases because we began with a basic oxide and we landed up into an acidic oxide, right? And reverse is true for the nature of acidic oxide. Is it clear to all of you?
Yes, ma'am.
Okay. Now then, as you can see, basic nature is decreasing in a period. So what will happen? In a group, the basic nature will be increasing here, and acidic nature, on the contrary of what we have learned for the period, will be decreasing, right? So you may be asked, then the question comes, what type of a question can be asked? Again, it can be related to periodic table, that an element is placed in so and so group. What do you expect about its oxide? The question can be asked directly, or that can be, I can ask the question in a different way also. How will it affect the, let's say, litmus paper? Do you remember litmus paper? What was the role of litmus paper in class 10th in acid bases salts?
Ma'am, to say whether the given solution is acid or base.
Correct, Ritika. But tell me what happens when you have litmus papers. Litmus paper is of two types, blue and red. What happens in acid and what happens in case of a base?
Ma'am, it turns red when it's acidic and it turns blue when it's basic.
If you dip blue litmus paper in acid, it turns red. And if you put red litmus paper in a base, it will turn blue. See, that can be one of the way of asking the question, that a certain oxide, when it was dipped in blue litmus paper, the color changed to red. It can be. Then you have to think it is turning blue to red. That means it has to be a basic oxide and it must be of group 1 or group 2. Instead of litmus paper, they may tell you the pH also. I believe you remember that also, that pH is a scale to find out the acidity or the basicity of a substance. That pH 0 or 1 to 7 is said to be acidic, and above between 7 and 14 it is said to be basic, right? So the question can be asked in that sense also. As we are moving towards the 11, moving quickly towards the class 11th, we must be preparing ourselves now to do a question which is based on amalgamation of 2 or more chapters of the same book or from the different books or classes rather, right? So coming to the chemical reactivity, this is important. For this is just an observation, there is no hard and fast rule for it. But since it is mentioned in NCERT, I have to teach you, right? To me, there is no particular point and we do not expect a question from it. Because reactivity to me can be understood or can be asked in terms of either ionization enthalpy or electron affinity. Because something will react only by giving out electron or by accepting the electron, right? So it is observed that chemical reactivity of metal increases when moving down the group. Again, answer as I told you, it should be lying in ionization enthalpy because they have to give out the electron. So what is happening? It is increasing and non-metals will decrease down the group, right? Now let us, even if you have seen the answer, let's solve this question. Can all of you see the question?
Yes, ma'am.
Okay, please solve and come up with the answer.
Is it option 3?
Okay, maybe. Because I'm very sure for the option that most acidic. I know that when we move from left to right, the acidic oxide nature increases. So the last one in the period is a Cl2O7.
Oh, sorry, I told for basic, sorry.
Okay. I'll again remind.
The third option.
Again, I say, Mritika, even I haven't seen the answer. I'm just trying to solve it with you. And again, when you are given a question with options, think logically how to eliminate the either the option is obviously correct or obviously incorrect. Else try to find out a part which may be correct. For me, nothing can be more basic than sodium oxide. It is group 1. And the most acidic will be Cl2O7 because it is the other end of the periodic table, right? So that means they have asked me for the order most basic, most acidic, and amphoteric. So most acidic has to be Na2O. Then most basic is Na2O. So A has to be the first, A has to be the first alphabet in my answer. It means I have eliminated the choice number 2 and 4. Is it making sense to Shweta and Ananya? Right now, purpose is not to find the correct answer. Right now, purpose is how to eliminate the incorrect options. Like if you have seen the KBC, how will you eliminate it? Making sense to you, Ananya?
Yes, ma'am.
That how I have eliminated the 2 options, right? Amphoteric, I remember Al2O3, right? So what will be my answer? B, it is saying B cannot be there, right? A, B, C, A cannot be the option for me. So the correct answer is, I think Ritika said the correct one, AEC. But I just wanted you to understand how should you reach at it. Either you should know what is which one is the amphoteric oxide. Then you find out that amphoteric oxide is Al2O3, which is placed in 3 of them. Not a good option. So then we have to bank on Na2O and Cl2O7, right? So coming to the next one, diagonal relationship. Can somebody put some light on it? What is diagonal relationship?
They are elements from different groups who have similar properties.
Okay. That definition is incorrect. I'll explain you why. The elements of different groups have similar properties. Now, can I say beryllium and sulfur will form a diagonal relationship? Or can I say nitrogen and chlorine will form a diagonal relationship? No. See, first of all, what is diagonal in terms of, I don't know which subject should I say it. See, between 2 lines, there can be diagonals in 2 directions. If these are my 2 lines, the one type of, this is a diagonal, right? And the other diagonal can be in this direction. Do you agree? Both of them are diagonals, right? But here what we are saying is that it is an observation. Till now, we have just learned the trends in the periodic table either vertically or horizontally, that is in groups or in periods. Now, we have certain observation. Please remember, diagonal relationship is not applicable to entire periodic table. It is said that when we move between second and third period, not all periods again, between second and third period, some members, not even the entire, some members of period 2 show similarity in properties with the elements of next higher group placed in diagonal. That means we are talking only of this diagonal. That is next higher group. If instead of it, I'm putting a diagonal like this, I'm talking about the previous group. Is this point clear to all of you? That where diagonal relationship is applicable in modern periodic table? Shweta, please respond.
Yes, ma'am.
Is this point clear that we are talking only the forward diagonals?
Yes,
We are
ma'am,
not.
this-
Okay. So here is the precise definition which I would like all of you either to copy or to remember or to use. That some, again, the wordings are critical, at least in this definition. Some elements of the second period show similarities in properties with the elements of the third period present diagonally in the next higher group, even though they belong to different groups. We can get away with this part of line if you wish to, but rest of the things are compulsory and they have to be worded like this so that no one thinks that you are talking about this diagonal. These diagonals are incorrect. Is it clear?
Yes, ma'am.
Okay. So if you want to note it down, just let me know. I'll wait for a second or a minute. Okay, moving on. Why does it happen? That is another, or what are the examples of it? Like beryllium, we have taken up this example that beryllium and aluminum show diagonal relationship. That means they must be having certain similar properties, like lithium and magnesium. Both of them react with nitrogen, but rest of the group members like sodium, potassium, or beryllium, magnesium, beryllium, etc., do not react with nitrogen to form nitride, but lithium and magnesium react with air to form nitride, right? Talking about beryllium and aluminum, I'm taking that example just because if you get a 2-mark or a 3-mark question, define this diagonal relationship, and with the help of one example. That one example I have picked up for beryllium and aluminum, one element from S block, another element for P block. That's the difference. Still, they show similarity in properties. The first and the easiest one, they're oxides. We have just done it. That aluminum is amphoteric. Beryllium and aluminum both form amphoteric oxide. The next reaction, if you wish, you can remember, else you may not, right? The carbide, like we have talked about oxide, hydroxide, carbide is also a type of anion. Beryllium carbide and magnesium carbide liberate methane when they react with water, whereas the carbides of group 2 and the group 3, that is the remaining oxide of these remaining carbides, carbides of these group liberate acetylene. We'll come to that later when we probably talk about hydrocarbons. So that's why I said you can delete or just leave the point number 2 for some time. But the first point is bit easy, which you can remember for your 2-mark question. Moving on. Why does it happen? Why certain elements show diagonal relationship? That is also an important and interesting question. So we say that they show certain similarity in properties. I've just put the periodic table also so that it is easier for me to explain how it changes. A smallest size of these atoms, if you remember, they have a very small size, right? Then high electronegativity. They are on the left-hand side of the periodic table. They have high electronegativity, large charge atom ratio, and absence of vacant d orbital. What do you mean by that? Do we realize that the members of the second period, they do not have vacant d? Are you able to understand the meaning of this statement? Absence of vacant d orbital, Shweta?
Yes, ma'am.
Absence of last point, absence of vacant d orbital.
I don't get the question.
What is the meaning? See, we say the heading
There
of
is
this.
no d. There is no d orbital.
Yeah. How does it? We are saying that the period 2 elements. Period 2 elements means we are talking about these. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. They show exceptional behavior. See, I'm not too sure why NCERT has retained this point in their books, although they are not dealing with the details of group 1, group 2, group 3, group 4 like that. Earlier, there used to be a chapter named as P block elements. Maybe next year you may get it in class 12. Right now, it is not there, but NCERT is free to change their syllabus. So therefore, I thought I'll just spend 2 minutes on it. We say that the second period members, they do not show. Last topic we did was chemical similarities or chemical reactivity. Many a times it is observed that the group 2, the second period elements, they do not show similarity in properties. Their properties are not identical with the group, the remaining group elements. What can be the reason? The reason is smallest size. When you go down the group, the size of element or the atom increases. In this case, lithium, beryllium, they are the first members of their respective groups. Their size is very small. Electronegativity, which is decreasing down the group, they have very high electronegativity. The next one you can understand, large charge by radius age ratio. The charge on entire group 1 elements is +1, right? Or 1 electron in valence shell. But the size of lithium is the smallest. If you divide them, numerator is same, but the denominator in case of lithium is the smallest. So they have large charge to radius ratio. Then the absence of vacant d orbital, that we have to cover it in the periodic, next chapter of chemical bonding. The classical question is that we know about NH3, nitrogen and phosphorus. They belong to same group, right? Nitrogen forms NH3 when it reacts with hydrogen. Phosphorus forms PH3, that is phosphine with phosphorus. Additionally, it forms PH5 also. But NH5 is not known. We know PCl3, PCl5. They are well-known compound, but NCl5 is not known. Is it clear to all of you that what is the meaning of absence of vacant d orbital how does it impact the elements? Ritika, is it clear to you?
Yes, ma'am.
Okay. Now we will solve, I think this is the last question for this particular chapter. It covers minimum 2 to 3 properties of a particular element. So take your 2 minutes to solve this. I'm putting on the timer for myself. And in case you are able to do it quickly, let me know.
It's option A.
Okay. Anyone else who has got the answer? I'll wait for 30 more seconds. Okay. See, one way of solving the problem was, we know the third period elements, right? And oxide of A is ionic, B is amphoteric. Amphoteric has to be third period aluminum. We have discussed it purposely many times so that it is inbuilt in your mind that aluminum forms amphoteric oxide, right? Then the phosphorus. Unfortunately, they have deleted P block from our syllabus. We must remember that phosphorus exists as a giant molecule named as P4. We call it as red phosphorus. Right? And A is ionic. That has to be magnesium, or it could have been sodium. So that means what will be the C part, that is phosphorus, giant molecule. Please remember, go back to carbonates compounds class 10th. Carbon was able to form giant structure, let that be in the form of a diamond or graphite or fullerene. Why? Because it forms a covalent network. So C must be having the highest atomic number. Then amphoteric will definitely be in between, because in the periodic table, we have most basic at left hand side and most acidic on the right hand side. So that's how you can get to the answer, right? Is it clear to all of you? Now, with that, we end up the chapter, and this is the summary, right? I have tried to group the similar properties at one place, that what is increasing and what is decreasing, right? These 4 properties, they increase. and then in a group and decrease in a period, right? Then in these 5 properties, it is opposite. Would you like to note it down or not? Okay. So let's start the next chapter. I think we still have 7-8 minutes left. So should we start the chapter?
Ma'am, you can give the introduction for the lesson, ma'am.
Okay, definitely. So next lesson we will be picking up is chemical bonding, right? So in the chemical bonding, you must have heard about 2 types of bonds. Can you name them? Or 3 types of a bond? Can you name them? See, the next chapter, as I told you, will be picking up the chemical bonding and molecular structure. Till now, you must have heard about what is a chemical bond, why some atoms form bonds and why some elements do not form bond. So I will ask you what chemical bonds you have heard about. You might have heard about only 2 types of bonds. One is a ionic bond. The classical example of it was sodium chloride, magnesium oxide, which you did in class 10th. Then there was a covalent bond, right? Which was sharing. And we said example was methane. You must have done ethene, ethine, all those things. Now, as we move to class 12, we will be covering one more type of a bond, that is coordinate bond. This one will be the new one. More importantly, we will understand what is hydrogen bond. Before we go further, let's say that hydrogen bond is, I say it is a misleading bond, misleading name. It's not actually a bond, it's just a strong attractive force. You will say all of them are, but it is exactly at times we do not say it's a part of a bond structure. Moving on, what we have in our store. When elements react together, they form different type of bond. Now here the task in class 11th is to explain how the bond is formed. So various scientists have given different theories to the formation of bond. Let me make myself more clear that if I say carbon reacts with hydrogen to form methane, how this formation occurs, what type of changes are occurring there, we will be discussing this year, right? So first of all, we will have to understand that there are many theories, many theories, and we just classify them into 2 major categories. One is called as, these are just based on observations, right? And the other one are having a quantum approach. Quantum approach means they have a certain basics which are related to structure of atom. So we'll be talking about both of them. First, we'll begin with in the next class, we'll begin with Coastal-Lewis approach to the bond formation. Then we will talk about VSEPR, valence shell electron pair theory. Then we will move to VBT, that is valence bond theory. And finally, we will understand MOT. To me, the most important from the perspective of examination is VBT and MOT. Although VSEPR is most widely used. Whenever we talk about the shape of molecule, you might have, if you remember, shape of methane molecule was described as, any guesses? Do you remember what was the shape of methane molecule? It was tetrahedral. To give you the glimpses, we say the shape of water molecule is, it is distorted tetrahedral. Like if I talk about BF3, we say it is triangular planar. So who decides it? It's VSEPR. Valence shell electron pair repulsion theory tells us this, right? Now, valence bond theory tells us how different types of bonds are formed. Talking about molecular orbital theory, when we have moved from class 10 to class 11, earlier you were knowing that the elements have electron in their orbits, which were given by Borbury's rule, 282, 286, like that. And then say copper like 2818, 1, something like that, right? But now what you will understand? You will understand how the electrons are filled in molecular orbitals. When we say that methane is formed, that means now like it's as simple as that if we mix red and white color, what do I get? I get a new pink color. That means existence of red color and white color, both are lost. Similarly, we say that when atoms react, we have atomic orbitals. Now, when molecules are formed, the electrons are filled in molecular orbitals, right? And we will be learning how the electrons are filled in molecular orbitals. They also again have another order, like we write it as sigma 1s2 bonding, sigma 1s2 anti-bonding, and it keeps on. So a sincere request to all the students is, please remember your Euler diagram, that above wala zigzag, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, like that. Only then you will be able to understand MOT better and do some practice on this. So first topic which we will pick up is Kozal and Lewis approach, which is just say they talk about what is kernel, what is different type of electrons, how they are filled, where the attraction is more, where the attraction is less, just those concepts. And before leaving the class, for the last chapter which we have covered, I have deliberately not touched upon the topic which may be there in the NCERT, named as lanthanide contraction. For that, I have a clarification that this is in class 12, not in class 11. It is a characteristic property of F block elements. If you have, Ritika, can you tell me, is lanthanide contraction in your 11th class book there still?
Ma'am, I still haven't seen it, ma'am.
Okay, please check.
Like, but they have taught me it in school.
Okay, if it, can any Shweta or Ananya, can you tell me if it is taught to you in your schools?
Yes, ma'am.
It is taught to you. Okay, have you understood, or Shweta, do you have any query about it?
A little, ma'am, like you teach and understand.
Okay, do remind me in the last, in the next class rather. I think,
Okay, ma'am.
do let me about it. I'll explain to you at least the section which is relevant for you, right? So that you do not lose your marks in the class. I will also put up a note for myself in case I forget. It's your I request you to just let me know. Let me remind rather so that I can explain it to you. So you'll be having your test soon on this chapter, that periodic classification. I believe you are going to score good marks because we have covered each and every detail. We have gone to each nooks and corners of the chapter. So now you can revise your chapters, solve your NCERT question, exemplar questions, and be ready for the test in next week or next to next week, right? So with that, I conclude the class and see you in the next one. Have a good day.
Thank you, Mom.
Thank you, ma'am.
Welcome.